Hey, welcome back to Math with Patrick. Today is July 3rd, and we're solving problem number 184 from the Daily Epsilon calendar. And we need to show why x is supposed to be equal to 3 today. So I'm seeing if x is 3, this number is 75, and I'm pretty sure the problem makers are saying that the area of this triangle here is supposed to be 75. So we should use something about, maybe these sides being equal, maybe some right angles, maybe, well, of course, these numbers to kind of show why we should get a 75 here, and then thus x would be equal to 3. Well, the first thing I see is that we have a right triangle and we know both of the legs, so I'm pretty sure it's pretty obvious we should use a Pythagorean theorem on it. Although I am going to use the Pythagorean theorem and similar triangles. I notice that this is like a 3, 4, 5 triangle in disguise. If I divide the 12 by 4, I'll get 3. If I divide the 16 by 4, I'll get 4. And then this number right here, doing the Pythagorean theorem, we would get a 5. So in our actual triangle, though, this means that the long diagonal here, the hypotenuse, is a 20. So now that we have some information about that blue triangle, I'm going to redraw it, and I'll make 20 that base. So now I have 20 as a base. These two sides are equal, and it would be really convenient to have this height right here, because if I did, I could just do 1/2 base times height and get the area of the whole triangle. And I think I could use the angles to find the height. So let's look at this angle right here for a sec. I'm going to use some inverse trig right here, using like SOHCAHTOA ideas. Tangent of some angle, I'll just use theta for now, is going to be equal to opposite over adjacent. So it'll be the opposite side divided by the adjacent side. Although I guess I could reduce this fraction. I could divide the top and bottom by 4, and I would get a 3/4. But I want to know what the angle is. Like, currently the argument of my tangent function is the unknown thing. And so fortunately, you can always rewrite these trig functions. Like if you know the answer and you don't know the angle, this is a great time to use an inverse trig function. Basically, you can just rewrite it as tangent inverse of 3/4 is equal to that theta angle that we don't know. The reason why I'm using this angle is because we have a parallel lines and transversal situation where I know that the alternate interior angle, this one, should be equal to the same one down here. That's why I'm using the same variable, theta, for both. Whenever you have parallel lines and a transversal, you're basically going to create 8 angles. There's 1, 2, 3, 4, and then 5, 6, 7, 8. And 4 of these angles are all small and congruent, and 4 of the angles are all big and congruent. So basically, I'm taking these small angles, and since I have this parallel line and transversal situation, I know that these small angles are equal to each other. So all of that just basically means this angle right here is tangent inverse of 3/4. And I could plug that into a calculator. I think this is like 37 degrees, but it doesn't actually matter how many degrees it is. Instead, what I can do here is use the 3 and the 4 and kind of proportionality of similar triangles to figure out what this length and this length should be. Well, actually, I do know what this length is. Cutting this triangle right down the middle, this one right here should be a 10. And now I know that this triangle right here, because the angles are the same in that corner, it should be proportional to my 3. Oops, actually, this is supposed to be the 3. This is supposed to be the 4, and here's the 5. So all the measures on this new triangle right here should be proportional to the 3, 4, 5 right triangle. I'm noticing that if I multiply 4 by 2.5, I'll get 10. And so to keep the proportions the same, I should multiply this 3 also by 2.5. So doing times 2.5, that gives me 7.5. There we go. And so now I know the base of the triangle, it's still at 20. I know the height, it's 7.5. And so if I do 1/2 base times height, maybe let's kind of simplify these ones and make it 10. and then multiplying by 10 is pretty easy here. So indeed, the whole area of the triangle is 75, and that must mean that x is 3 today. So there's my solution. Thank you for following along. I hope you enjoyed, and I'll catch you in the next video. Bye.